Okay, so this video is going to be on how we're going to do the math to make a 10,000 part per million standard solution for jar testing in 1 liter beakers. Most water plants are going to have 2 liter beakers. I have a few folks that use 1 liters. I actually was doing this video originally for a client using 1 liter jars. I'll point out the spots here where someone with 2 liter jars, needs to modify what they're doing. Basically, you're going to have to make your solution twice as strong. So the point of making a 10,000 parts per million solution is that when we add 1 milliliter of that 10,000 part solution to a 1 liter jar of raw water, it's going to give us a dosage of 10 parts. So if we need 10, if we want, like say we wanted 90 parts, we can add 9 mils out of the syringe, and we'll have our dosage that way. Another way to do it is with a micropipette. Now, micropipettes are pretty handy because we can completely skip that step where we're making a stock solution or standard solution. We can do things a little bit faster, but for right now, we're gonna focus on the old school way to do it with syringes. So let's see, where are we at here? Okay, so the first thing we're going to have to do before we can make up our stock solution, if we're just doing all of our math from scratch, we're going to have to get some information on our bulk chemical. So let's say in this case we're going to do aluminum sulfate as our primary coagulant. So the first thing we're going to need to find out what our specific gravity is. So the specific gravity, let's say for this particular load of aluminum sulfate we're going to say our specific gravity is 1.33. And then let's say we've got 48% solids. So 48% solids. Okay. That's our starting information. All right, so what is the specific gravity? So the specific gravity is the relationship between the weight of water and the weight of our chemical. So we know that water weighs 8.34 pounds per gallon. And so whatever the pounds per gallon of aluminum sulfate, that number, when we divide by 8.334, is going to give us 1.33. Okay, so what is that number going to be? That number is going to be 11.1. So 11.1 pounds per gallon. Result's going to be 1.33. It's going to work with any units because we're dividing out those units right there. And the math for this is going to be using cross multiplication and factor label, dividing out units and that sort of thing. I know a lot of folks don't have a real good grasp on that, and it's kind of difficult for them. But I'm working on a way around that to help some folks out. I teach at classes and whatnot, and I've gone through the North Carolina water plant operators training. So I hear a lot of the issues. So we're going to work on that. But okay, so a little side there. So specific gravity 1.33. And that let us get 11.1 pounds per gallon. So 1 gallon of our aluminum sulfate, in this case 1.33, 48%, is going to equal 11.1 pounds per gallon. Okay, and we're figuring we're figuring this stuff based on the dry weight. So we need to know how much dry material is in that 11.1 pounds per gallon, so we can get a correct parts per million, which, as you know, is the same as milligrams per liter. Also going to do a video on the pounds formula to kind of explain how that relationship works. Okay, so to find out how much dry material is in there, we're going to multiply that by 0.48, and our result here is going to be 5.33 pounds per gallon. And like I say, this is going to vary, pretty much vary. Usually with aluminum sulfate, you've got a range of 48 to 50%. If you want to look at your C of A or your product data sheet, whatnot, to get this information right here, you can, and you can recalculate your standard solution every time you get a new load if you want to. You won't find a whole lot of difference in it, but I would recommend making a new standard solution every time you get a new load of your aluminum sulfate, so that you'll be consistent between what your jars are telling you and what you're seeing in the plant. So we said, okay, we've got 5.33. Okay, so this 5.33 pounds per gallon, that's actually a concentration, just like milligrams per liter. It's just in English units, so we've got a weight and a volume. So what we're going to have to do before we can figure out how we're going to make our stock solution from our bulk solution is convert that to metric, to milligrams per liter. So let's take this off right here. We said, all right, weighs 11.1 pounds per gallon, and the concentration was 5.33 pounds per gallon. All right. Okay, so how are we going to convert that? Well, it's pretty straightforward. First thing we're going to do, we're going to say we've got 5.33 pounds. Let's see how I want to do this, per gallon, right? Okay, then I'm going to convert my weight, my mass first of all. So 1 pound is the same as 454 grams, right? Okay, so we can cross out our pounds here, times, all right, 1 gram is equal to 1,000 milligrams. So we can divide out our grams there. So now we're going to have milligrams, and 1 gallon is the equivalent of 3.785 liters. So our gallons are going to cross out there. Going to divide out, and what our end result here is going to be 639,318 milligrams per liter. So here's our concentration. This is our concentration of our bulk solution. 639,318 milligrams per liter. So that's a pretty highly concentrated solution there. So we need to know now how much of this highly concentrated solution do we need to add to 1 liter of distilled water, so we'll have 1 liter of our 10,000 part per million stock solution. So we're going to write that number up here, 639,318 milligrams per liter. Give you a second here so you can see that. Pause if you want to. Okay, now there's another equation that we're going to use called the continuity equation. It pretty much tells us that if I've got one high concentration solution, how much of that solution do I need to add to some volume, in this case 1 liter, to make a solution, in our case a 10,000 part per million solution. And if you want to see how it's actually written out the long way, it's just C1 equals C2, C1 V1 equals C2 times V2. But we can also just go ahead and write it out, solving for V1 if we want to avoid doing the algebra on that. So our volume here, we're going to call this V1. This is going to be how much of our bulk solution we're going to need to add to 1 liter is going to equal C2, okay, V2 over C1. All right, that's times. Okay, so this is the solution we want. This is going to be our standard solution. This is going to be our standard solution right here. And this concentration, this is going to be our bulk solution. All right. So, let me erase this right here. So our concentration that we're trying to get, that's on top, that's our standard. It's going to be 10,000 milligrams per liter, right? We're going to have 1 liter. And the concentration of our bulk solution is 639,318 milligrams. Okay, had to pause there for a second. So we've got our standard solution over the concentration of our bulk solution, and it's going to tell us how much to add to 1 liter of deionized or distilled water to make 10,000 parts per million. All right, so we're going to do the division thing here. The units are going to divide out again. And we are going to get V1 is going to equal 0.015642 liters. Okay, and nobody say anything to me about significant digits because I don't care. So 0.015642 liters. We're going to have to convert that to milliliters. So 1 liter is 1,000 milliliters. Divide that out. So what we end up with here is 15.64 milliliters. So I'll take my 16.4 milliliters, put it in there, and 1 liter of distilled water, and then I will have a 10,000 part per million stock solution. If I only want to make, only want to make 500 meals, I'll take half of that number. If I want to make, let's say I'm using 2 liter jars, right? Now I've got 2 liters I need to deal with, so I'll have to make it twice as strong. So I'll have to make a 20,000 part per million solution, and that way 1 meal into a 2 liter beaker will be correct, will be 10 parts per million. So I would have to double this number, or I could use that same amount and use half the volume. So if I added 15.64 meals into 500 milliliters, I would have a 20,000 part per million solution then, and that's what I would use for my 2 liter jars. I would not make a 10,000 part solution and then use it with 2-liter jars and just try to double things up. All that'll do is end up confusing you. Just go ahead and make twice the strength, and then each 1 mil, 1 mil will be 10 parts, and you'll be good to go. Now on the polymer side, we'll actually be making 1,000 milligram per liter solution. So with polymer, 1,000 milligram per liter solution is going to give you 0.1 mils equaling 0.1 parts, or 1 mil equaling 1 part. Same thing into a 1 liter jar of raw water when you're doing your testing. And of course, you do the same thing strength-wise if you needed to make a 20,000 or 2,000 part per million if you were using 2-liter jars. So yeah, that is pretty much that. See if there's anything else that we need to talk about. And I believe this is it. I'm probably going to do some more videos on jar testing. Maybe set up my kit. Maybe set up my portable salesman's kit, and maybe I can find a plant that'll let me use their 2-liter unit and run some jars on that. But anyway, I hope this helped you. Hopefully we're going to have more to come here, so we'll be able to get all kinds of knowledge. I may do some videos with ferric, but this process is going to work the exact same with any chemical. You just need to know the specific gravity. Sometimes you might get lucky and you might already have the pounds per gallon. You might get that from your supplier or a data sheet or the C of A when your load is delivered. Sometimes it has different information on it. It just depends on the manufacturer. A lot of times with alum, they like to use something called the Balme scale, which you don't really see a whole lot of that, but for some reason the aluminum folks still like it. If as far as to get an idea what your specific gravity is, your density and all. But anyway, other than that, get in contact with your supplier and they'll be able to tell you. If you're an Americhem customer, let me know. All right. That does it.